Hey guys, so today we are going to continue working on polynomials. Last class we learned how to add, subtract, and multiply, and today we're going to look at how do I divide polynomials. And so I'm going to show you two strategies, and you can choose whichever one you like to do your homework. Okay, so the first one is a little bit longer and not the shortcut, the longer one, but it is more familiar and you've seen it before. It's called long division. And so let's start with the left side. How do I divide real numbers using long division? So if I ask you to do 950 divided by 15, how would you do it? And you might recall from elementary school that you would put the divisor, which is 15, on the outside, and you would put 950, which is the dividend, on the inside. So some quick vocab. Whatever we are dividing by, that's our divisor. And what we're dividing, that's our dividend. Okay, and then you would ask yourself, okay, 15 goes into 9, how many times? It doesn't go in. So then you would say, all right, how about 15 goes into 95, how many times? And that would be 6. 15 goes into 95 6 times with a remainder of 5, right? So then you would multiply 6 times 15, that's 90, and then you would subtract. And then you would get 5. And then 15 doesn't go into 5, so then you're going to bring down the next 0. And then you say, okay, 15 goes into 50 how many times? You would say 3. 15 times 3, that's 45. And then you would subtract again. And again, you would get a remainder of 5. And then there's nothing else to bring down anymore. So then the next question is, okay, what do I do with that remainder, right? Instead of writing R5, which we've did for a while, you might recall that, oh, I could like add a decimal and add a 0 and keep bringing down zeros, and then you're going to keep getting remainders of 5, right? Because then it's going to be 50, and it's going to be 3 again, and then 45. And then you bring down another 0, it's going to be 3, and then you see that the pattern repeats, and you know, oh, this is just 63.3333, which is just 63 and a third. And so instead of continuing to bring down zeros and continuing to divide, you can actually stop once you get down to the remainder and there's nothing else to bring down. So what we can do is we can rewrite the remainder as a fraction over the divisor. So 5 over the divisor is 15, and we can reduce that fraction. 5 over 15 is 1/3. This is just 63 and a third. And so that's how we get that 63.333. Okay, so remember what we did here, and we're going to do the same thing with dividing polynomials. So let's look at the right side. We're going to divide x squared plus 3x minus 42 divided by x minus 5. And so we are going to draw our dividing symbol. And then on the outside, we have x minus 5. That's our divisor. And now our dividend is x squared plus 3x minus 45. Okay, and so again, I'm going to look at, I have two terms on the outside, right? X minus 5. So I can't have it just go into x squared, which is one term. So I have to look at the first two terms. And I have to think about, all right, what can I multiply x minus 5 by? I'm going to put it up here, whatever it is, so that when I subtract, just like how I subtracted this 90, I subtract at least that x squared away. So whatever I multiply by, so x minus 5 goes into x squared plus 3x how many times? And whatever I multiply by, I want to make sure that when I subtract, I at least subtract away this x squared to get rid of that first term. So really I'm asking myself, x, this x, times what will give me x squared so I can subtract it away? And the answer is x. And so I'm going to put that in the x column. Okay, and then I'm going to multiply, just like how we did 6 times 15, that's 90. I'm going to multiply x times x minus 5. So x times x is x squared, x times negative 5 is negative 5x, and then we're going to subtract. So I'm going to minus, and then remember you're subtracting both the x squared and the negative 5x. So when you minus negative 5x, it's going to become a plus 5x. Minus a negative becomes a plus. So one rule to remember is you draw the line to subtract and you switch the signs. Draw the line, switch the signs. Okay? And so x squared minus x squared subtracts away, and then you've got 3x plus 5x is 8x. And then we bring down the next term. And then we ask ourselves, okay, next time I want to subtract away that 8x. So again, x times what will give me that 8x, so we can subtract that away. And the answer is 8, right? X times 8 would give me that 8x, and it's a positive 8. So I'm going to put positive 8 right here on top of the constants term. And then I'm going to multiply again. So 8 times x is 8x. 8 times negative 5 is negative 40. And then I'm going to subtract. So subtract the 8x, subtract the negative 40, which makes it a positive. 8x subtracts away, and I end up with negative 5. And I have nothing else to bring down. Okay? And so that's our remainder. And we're going to do the same thing. We're going to write the remainder as a fraction over the divisor. So that's going to be minus 5 over, our divisor is x minus 5. And if your remainder is 0, then your answer is just x plus 8. But if you have a remainder, you add it as an extra term as a fraction over the divisor. And that's how you do long division. Okay, let's try one more. Again, with real numbers first. What if I ask you to divide the year 2025 by 7? And you don't actually have to do it. What I want you to make note of is, so I'm dividing by 7. How do you write the number 2025? You write 2025, right? 2025. I want you to think about what the row of the 0 is. 2025, you didn't write 225. You put a 0 in the hundreds place as a placeholder because there's no number in the hundreds place. And so sometimes we need a placeholder when there's a missing term. And so let's do the next problem using long division on the right with polynomials. Again, I'm going to set it up. I'm going to put x minus 2 in the front. That's my divisor. And my dividend is x to the third. But look, I don't have, the next term should be an x squared term. But I don't have that term. So I'm going to put in a 0x squared as a placeholder for the x squared term. That should be there. Just like how I put the 0 as a placeholder for the hundreds place in 2025. And then, so x cubed, x squared, and then next I have the x term and then the constant. So everything else is fine. All right, so now we're going to divide, okay? We're going to go into the first two terms. So we're looking at x minus 2 times what will allow me to subtract away this x cubed. And that would be x to the second. So I'll put that on top of the x to the second column. And then I multiply. So x to the second times x, that's going to give me that x cubed. And I want to be able to subtract that away. And then x squared times negative 2 is negative 2x squared. And then I subtract. So minus x cubed minus negative 2x squared. So that's a plus 2x squared. And then I add my column, so the x cubes cancel out. 0x squared plus 2x squared is 2x squared. And then I can bring down the next term. And the next time I subtract, I want to subtract away that 2x squared. So I think about x times what will give me 2x squared. And that is 2x. Right, so I'm going to add 2x here. And then I'm going to multiply. So 2x times x will give me 2x squared. 2x times negative 2 would give me negative 4x. And then I subtract again. So minus 2x squared minus negative 4x, which turns it into a plus. The 2x squares cancel out. 1x plus 4x is 5x. And then I bring down my last term. And the next time I subtract, I want to subtract away that 5x. So we think about x times what will give me 5x, and the answer is 5. Okay, so then we multiply. 5 times x is 5x. 5 times negative 2 is negative 10. And then I subtract one last time and see if we have any remainders. So that would be minus 5x minus negative 10, which turns it into a plus 10. And no remainders. 5x minus 5x, negative 10 plus 10, cancels out, and you have a remainder of 0. So x cubed plus x minus 10 divided by x minus 2 is just x squared plus 2x plus 5. So that is long division.